Hey everybody, and welcome back to another Blender tutorial that I have been avoiding making for a long time because it's geometry nodes, and to be honest with you, up until this point, I didn't feel like I had a good grasp on it, and chances are you have no idea what the you're talking about either. So today, let's make this like abstract time-delayed sphere. I don't even know what it is. We're going to have a lot of controls over it. You're going to learn pretty much all the basics there are to know about geometry nodes, and by the end, you're gonna feel awful, but you will have learned something in the process. So, this is the scene we're making. It's like a circular centipede thing. I feel like I've had a nightmare of something like this going up my butt, and that's the inspiration for this one. Either way, we're making this kind of thing, which actually was not possible without geometry nodes, because you could do an array modifier, but there's no way to time delay this transformation even with object offset. But the thing is, once we lay down all these nodes, not only do we get this cool result, but additionally, we can control a bunch of stuff. So I can control the resolution. How many circles are there going to be in this thing, right? So I'm going to set it to 50. What's the speed of it? Should it be going super slowly or super fast? Or should it be going in the other direction? Another thing is the spread. I'm just calling it that. That's kind of like the movement of this like smallest point. Is it going to be very big? Or is it going to be very centered on the middle? Or does it even extend beyond? Okay? These nodes are going to allow us to do all this and more, except not really more, because these are the parameters I picked. But, you know, you don't need to know anything about geometry nodes to get started. This is like a from the beginning style tutorial. So make sure you have Blender 2.93 or above. I'm using 3.0 because that has the newest nodes, but I don't think we're using those. So either way, make a blend project. Done that? Cool. Next, you're going to go to Geometry Nodes Workspace. We're in Geometry Nodes. Beautiful. For those of you that don't know, basically this comes with a 3D viewport, as you'd expect. Geometry Nodes window. This is where we're doing our work. And a new workspace called I think it's called Spreadsheet. Yeah, Spreadsheet editor that gives us all the data of all the things we're modifying. This one we're not going to be using too much, okay? So with your cube selected, make a new node network. So this is our geometry nodes network. We could call it butt centipede thing, which is what we're making. And you can see this cube had a modifier applied. It's a geometry nodes modifier, and it's called butt centipede, okay? We're all clear on that. Beautiful. I'm going to take this group input and delete it, which is kind of a new way to delete the default cube. So again, this geometry is now reading from this modifier, and there's nothing going into it, so the cube doesn't exist. So to make this kind of butt centipede thing, here's the theory. We're going to make basically a spiral, so we're going to make a line, turn it into this moving spiral that we want to be able to animate, and for each point on that spiral, we add a circle. Right? So now we have a stack of circles going in a spiral. That's going to be the thing. So the main question is, one, how do we make the spiral? And two, how do we copy circles onto it? So starting off with the spiral, just like any other node editor and whatever, Shift A to find a node. In this case, I want a line, which I think is in Mesh Primitives, and you can see there's a line. Additionally, or alternatively, you just type in line like not a schmuck. So connect the line. You can see this creates a line for us that we can control. So how many points does it have? That's something we can make on the fly or change on the fly. And importantly, the spreadsheet editor is going to show us each of these points. If I have 8 points, it's going to show us 0 through 7, starts indexing at 0, and it's going to give us the X, Y, and Z position of each of those points. Okay? Fine. What I'm going to do is instead of offset, I'm going to set this to endpoints. So instead of it like getting taller and shorter and all that, I want endpoints. So no matter what resolution we pick, it's going to stay the same height. I'm going to go from instead of 0 to 1, let's make it 0 to 5 just so it's a bit taller. And you can see we changed the vertex count. The height doesn't change, but we do get more geometry over here. So you want to think of this as subdivision of the line. Let's start off with like 10. So we have 10 vertices, 0.5 something, 1.1, whatever, as it goes up to 5. So it's going up in tenths or something like that. Okay? We want to take this and somehow extract this X, Y, and Z data so we can modify it and turn it into a spiral. Well, currently, all of this is packed into a single attribute called position. So what I'm going to do is I'm going to do an attribute separate by X, Y, Z. which takes a input and separates it into 3 components. So for example, I just click this. I don't need to know the name of anything. It already tells us all the attributes that already exist for this line geometry, and that's just going to be the crease for some reason and the position. So I'm taking this line, reading this data, and we want to take this and separate it into 3 attributes. I'm going to call the first one, so I'm making one. I'm making a new attribute. I'm not picking one that already exists. So I'm creating the X attribute, the Y attribute, and you can see it's populating here, and the Z attribute. So again, it's taking this kind of like vector kind of input, so this position X, Y, Z, and separates it into the first column, bunch of zeros, second column, bunch of zeros, and the third column, which is the Z, or the height of every point on the line. So in other words, we've just taken this and separated it. Cool. Now that we've done that, we can also do the opposite. So we can now combine X, Y, Z attributes. Again, this is the new workflow, and this is why it's taken me a hot minute to start making geometry nodes tutorials, because it's kind of a different way of thinking. It makes sense. I don't like it too much, but whatever. So here I'm combining 3, and in this case I'm going to combine X, Y, Z, but you can see when I click this, we already have our X, Y, Z because we've already defined these attributes. And an important thing is these attributes are kind of like dependent on the chain. So you can see if I click this, there's no options, whereas this one does have options. That's because it's going down this chain. This one's not connected. Okay, so make sure it's connected. By the way, the reason I keep scratching my nose, it's not drugs. I'm just allergic to stuff. Dust, I think. Dust mites. I need to get it checked. Either way, we've separated it. Now we're going to combine it back into position. So long story short, we've done nothing. Okay, we've taken position, separated it, and then rewrote it by combining these. The interesting thing is, what do we do in between? So what we are going to do in between is turn this into a spiral. So let's do a attribute math. So here's where it gets a bit mathematical. So what I want to do is I want to turn this line into a spiral. In other words, instead of just going straight, it should kind of have a circular quality to it. The way I'm going to do this is I'm going to take each point as we go up and say, look at the Z location, in other words, the height, and use that as a sine or cosine kind of thing. Again, these are the functions that give us the XY position on the unit circle. Okay. So long story short, what I'm going to do is I'm going to do some attribute math, set one of these to cosine, another one to sine. I'm going to take a input, so we are doing cosine to what? To the height, Z, and we're writing it into X. And this is kind of an important thing. So the way these math nodes work is we take a input, so it's either going to be A, or if you have like something that has 2 inputs, A and B. You take an input, so I'm taking Z, the height, I'm doing a cosine to it, and I'm writing that result into X. In other words, I'm overwriting it, okay? So you can see this data now has things that aren't zeros. Before, zeros, but now we're writing new stuff to the X. We're replacing the X. You can see this kind of gives us a spiral thing, at least on the X-axis, and now we just need to repeat it on the Y-axis. I'm just going to duplicate it. Again, we're doing a chain of math, which is kind of why I don't like it too much, because I kind of want to separate my nodes and not just have it be a long line. Whatever. We're going to do this. So for the other one, we're going to take the sine function and write it to the y. And you can see this gives us a spiral. Again, for each point, we add this line. We said, look, let's take the height as our parameter, the z, and take sines and cosines to make a unit circle. So if we look at the top, you can see it's kind of closing in on a circle. And we can change the resolution of that. How many points is it calculating for? But the math is the same. Okay. Cool. So now we have a thing. We could copy our circles onto the spiral, but the thing is, if I play this animation, so right now it's playing, nothing happens. It's just a stationary, static spiral. And of course it is. Nothing's changing. So the next order of business is, how do we animate the spiral? How do we have it spin? Well, if you think about it, sine and cosine is defining our x and y locations that are being written here. So to animate those, we need to animate the z parameter, because it's all dependent on z. Here and here, we're taking sines and cosines of it. So what I'm going to do is I'm going to do an attribute math. I'm going to do an addition in this case. And what we are going to do is this has 2 inputs, z and something else that we haven't defined yet. And we're going to write over to z. So again, I'm using z in the calculation to overwrite z. It's kind of like a programming thing with that equals sign. Everything to the left is being assigned the stuff to the right. Don't worry about it too much. What I'm going to do is I'm going to set this second input, so b, instead of an attribute, I can just make it a number. That's what a float means, which means now I'm taking z, the attribute, the height from the line from before. I'm going to add a number, and that's going to be our new z, which everything else is dependent on, which means if I change this, whoa, we got a spiral, and it's kind of like a weird situation where it's almost like going up this predetermined path, which, by the way, is a cool way to do a kind of MoGraph animation. Ducky, credit me when you steal this. I'm kidding. We have a thing. The issue is, of course, that it's going up and down. We just want it to be spinning in place. Let's think about why that's the case. Well, again, z's changing because we're adding something to it. So you can see we're literally just adding values to every spot here, and that's changing everything else. That's affecting x and y, but the issue is, again, our final position is taking this z input as the third input for our position. In other words, if we add something to this, it's going to move all the z coordinates up, but also do the sine and cosine. So what we need to do is we somehow need these calculations to be dependent on z, but not have this one change somehow. Here's how we are going to do it. We're going to use a buffer or like a temporary variable, the same thing you do in a coding, okay? So for example, we're going to do the same idea here. But instead of using z every time, I'm going to create a new variable and use it for that. So for example, instead of overwriting back onto z, I can make a new one called z time because it's changing over time. So I'm going to take this new attribute we made. I just defined it. It's defined by z, the height plus some number. I'm going to take it and I'm going to copy it onto here. Okay, not onto this one because I still want the original height. This is going to make it so that when I change this, it is changing z time, this new thing, right? But you can see, while z time is changing, z is not. It's static because, everything else is using a z time, and then we just copy it over. So you really need to have a mental map of what's going on here, right? We took a line that has position information. We've separated it into x, y, and z data. I took the z. I said make a temporary variable called z time, which is defined by this. Do some math, sines and cosines, and then paste everything. So these are the modified x and y, and this is the original z. That's the the map. And I'm trying to go as slow as possible. If you don't get it, you got to rewatch it at this point. But okay, so we got a thing. So we can animate it, and it's a spiral, which is cool. So now let's take advantage of this. So like in any part of Blender, you can use drivers, anything like this. So I'm going to make a value. I'm going to type in hashtag octothorpe #, tic-tac-toe board, whatever you want to call this thing. Type that in, hash frame. What that's going to do again is it's going to make a driver that looks at the frame number. So I'm just going to open up a timeline here. So here we're on frame 1. This has value 1. As we go down the timeline, frame 8, 9, 10, blah, 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 you can see it's updating here. So we can connect this, and this is going to animate our spiral because every frame it's going to be adding something new to z time. We also want to be able to have a bit of control over this, I guess. So let's add in a math node. We divide. In other words, we're going to say, do we want to slow down, speed up time, whatever. So I'm going to take hash frame, divide by 10. That's going to make it 10 times slower. If it's 50, 50 times slower. If it's 2, it's still going to be pretty fast. And negative means reverse the polarity of time, which makes the spiral go the other way. So this is actually one of the parameters I had exposed over here. So here's how we do it. Let's add in I deleted it before when we deleted the cube. Group input. So this is basically saying what parameters do we want for this butt centipede modifier. I'm just going to say, one of these should be this thing that we've created, right? And now we can control it from here. So again, reverse polarity, normal, faster, slower. You get the idea, okay? So this is just exposing these parameters over here. And by the way, if you hit N, the N menu, we can totally rename this to speed. I mean, that's what it is. And I think we don't need this geometry input, so I can get rid of it. Seems fine. Seems to work. Okay, let's save our progress. So I'm just going to call this thing Patreon because you already know the drill. Blend's going to be available on Patreon. Tutorial's free, though. Okay, so we have the spiral. It's moving And at this point, we could start copying our circles onto this. So every point, again, the spiral is made out of points that we can, make more or less dense, and it's still going to work. And it kind of looks cool when it's a low resolution like this. But either way, we can copy a circle or instance it onto every one of these. I'm going to do a bit more work on this, and then we'll do that. So currently, we have a spiral. It's kind of like equidistant from the center. It's almost like a circle if you look at it from this view. And by the way, to close the circle, you just need to make it a bit taller, I believe, like that. But whatever. We have a circle, but it's all kind of equidistant. I want it so that I think the bottom, so like points near the z equals 0, I want them to be spinning less, and the ones at the top to be spinning more, so that they're all kind of moving together, but at different speeds, which is what makes it look interesting. To do this, what I need to do is I need to take this sine and cosine xy operation and basically say, don't do it that much at the bottom, but do it a lot more at the top, okay? If you get what I'm saying. An easy way to do this is I'm just going to do a bit more attribute math. In this case, I'm going to do multiplication. There's probably a faster way to do this with attribute mix, but again, we're trying to keep it simple here. So what I'm going to do is we've already taken this x and y and overwritten it to make it the sine cosine business. I'm just going to take that, so that's already happened. And now I'm going to do an additional operation. So let's start with x. I'm going to do something to x and then write it back over. So we're using x as part of the calculation, and then we overwrite it again. So I'm going to take x, and I'm going to multiply it by, let's say, z. Okay? What this is going to do, remember, z goes from 0, because we made a temporary variable, it's not changed. It goes from 0 up to 5, whatever our endpoint is, okay? Which means at the bottom, it's not going to be doing much, and at the top, it's going to be going much further, 5 times the magnitude. Kind of what we want, so let's take this, copy it again. This time, I'm going to do the same operation. By the way, important note, if you modify as the animation's playing, you get this error, so don't. Let's do it on y. So now we've scaled this so that the center, and you can see it kind of looks more like a spiral when we look at it from the top down. We've taken it, we've scaled kind of this sine cosine business to 0 on the bottom, and as it goes outwards, it gets bigger, which is kind of what we want. I just don't want it to be as intense at the top. So again, just like before, we had this thing dependent on z. Let's make a temporary variable so that we don't have to mess with it again. So attribute map range, new node, we'll talk about it. So again, we don't want to mess with z, so let's make a temporary variable. So just like before, we're going to take an input, being z, this thing that we're using for the multiplication, and I'm going to write it into a new attribute that we're going to make up. So I'm going to call this one z scale. Or really, I think what I called it last time was z spread, because it's going to end up looking like the spread of these circles. But either way, I'm going to take this, just replace these, so now it's all dependent on this new temporary variable. And here's what we want to do with it. So map range takes a input interval, 0 to 1, 0 to 5, whatever, and sends it to a new output interval. So in this case, we take z, the height of the original line we had all the way back here, this line. We say that it goes from 0 to 5, because the first endpoint's 0, last endpoint's 5. We take that and we want to do something to it. So because of that, we have a input interval of z going from 0 to 5, and I'm going to send it to 0 to 5. So right now, nothing's changed, okay? We just made it the correct start and end point. So we're going from 0 to 5 on height, and now I want to modify it so that it doesn't get as intense. So I'm going to take this 0 to 5 interval, and I'm going to map it to something smaller. I'm going to shrink it. So instead of 0 to 5, I'm going to take this and shrink it to 0 to like 1 or something like that. And you can see effectively what this does is it's kind of like a magnitude slider. It's not going to affect this bottom point because that end point is 0. So it's always going to be 0 no matter what we map it to. But it makes the most extreme part at the top less intense. So that's going to be the spread of it, if you want to think of it that way. And just like last time, let's expose this. So I'm going to put this right there. And we're going to call this new variable, or this new parameter, we can call it spread. So what do we have so far? We have the speed. How slow should it go? Should it go fast? Should it go slow? How fast is it spinning? We also have the spread. How far out does it reach? Stuff like that. And I guess we also have the resolution. Why not? So this is the count. Is it going to be a low resolution spiral? Is it going to be a high resolution one? How much data is going to be filled in here? So let's go back down to like 20 or whatever it was at. Okay, we have this spiral, and I think we might do more modifications to it, but now let's start adding in geometry that it's now pulling around. So again, we have the spiral that's going to drive the motion. Okay, how do we do this? Well, remember this line is made up out of, in this case, 20 points is what we picked. We can have it be any number of points, but it's made up of 20 points. We now have those points moving because of some math we did. And what I want to say now is take each one of these points with the motion and copy a circle onto it. In other words, we are going to take all of this, and at the very end, let's add in a point instance. It's going to copy something onto every one of those points. So again, we've taken our spiral, connected it, and now all we have to say is what do we want to copy onto it. So you could, I don't know if this is going to crash it. I've never tried copying lights. There you go. You can copy a bunch of lights onto the spiral. That's kind of a weird one. You can have a dynamic lighting setup. Or you could have a camera. Yep, that seems to work. Whatever you want. So what I'm going to do, and by the way, I think this is a thing that hopefully will change with geometry nodes. I want to be able to put something here and then input it in directly. Whatever. I don't think there's an object. Oh, no, there is an object info. Well, what are you going to do? Either way, I'm going to make a new mesh. I'm going to make it a circle, and for that circle, I'm just going to make it higher resolution and fill it in. Okay? This is just how you make a circle in Blender. Don't worry about it. For this, which we can call Geonodes, which originally was a cube, for Geonodes, we now want to say point instance what? The circle. Okay? And I'm just going to hide the original. This is going to make it so that each one of these points, that again are, dependent on the motion we did, is now going to inherit a thing. And the more or less circles we have is, whatever. Okay, so this kind of looks correct in terms of the motion, right? It's not spinning very much on the bottom, a lot more on top. But it kind of looks, plain and weird and not like the original result. And the key insight here is, I'm just going to go back to the original. The key insight here is it has the same kind of thing, except all the circles aren't the same size, right? The bottom circles are big, the top circles are small, and the motion's determined by what we already did. So all we need to do is change the size of it. In other words, the scale, the size of the points. Well, there's a node for that. We're going to call it point scale. Whenever you don't know, type in what you think it is, and if not, go to the point section, see what there is. So point scale, I think we could do this either before or after, because the points exist before and after. I'm leaning towards before, because maybe once we add in these circles, those are also considered as points right now. I don't know, to be honest, but I'm going to put it in before, because that definitely makes sense. So point scale, we could have a different kind of input. So you could have them all be the same number, or you could have a vector where, they're one thing on the x, one thing on the y, whatever. Of course, we want to do an attribute so that each one of these is going to have its own size. As we go up, it gets smaller. In other words, that's going to be dependent on the z yet again. So it's not z, it's not z, which is what we want, but it's some function of z. So if I type in z here, you can see it's kind of correct. It's inverted, so all we need to do is invert it because the smallest thing's on the bottom, biggest on top. So if we could somehow flip this, right, the same way that we've done things with z before, right, with z spread and z time and all these, that's what we want. So I need to make a new function for z. Just like before, I think this time I will also use map range since it's kind of what I want. This time I'm going to make a new temporary variable. We can call it z scale because it's going to be the scale of these points that's going to be dependent on the z. It's a new attribute. And what I want to do is, again, it goes from 0 to 5 because the first endpoint's 5. If this was 6, I'd want to put in 6, right? We want it to go from 0 to 5 to, we want to invert it so that the whatever was at 0 before is now big. So let's say that's 5, and whatever was the other is the flipped. Okay, so let me put that in. So 5 to 0. So again, what I'm doing here is I'm taking a input interval 0 to 5, and I'm just saying flip it 5 to 0. So wherever there was 0 before, make it 5. Wherever there was 5, 0. Flipping the interval. You can see this now gives us, especially from the top view, it gives us the correct look. And what makes this look really cool is you make it dense, right? You add in more points, so it's going to copy more. And this is the kind of thing I think is easier to see when you enable shadow and like cavity. The more we add, the cooler it looks, but you can also have a few circles if that's what you like as well. Again, we can control the speed. We've talked about this a bunch, but like everything we've done, it generalizes its stacks. And now you can really, I'm going to make it a bit slower, now you can really see what the spread parameter is doing visually. It just looks cool. It's changing before we even copied these, it's just changing the size of the spiral and how far it reaches out, right, the spread. Okay, so let's increase the resolution here. So I've picked a spread so that these like tiniest circles at the top are just barely brushing. It should be 5 or, yeah, I'd imagine 5 is the number for the spread because it seems like everything we've done is dependent on this number 5. Okay, we got a thing. Let's make it higher resolution. This is the beauty of geometry nodes. Once you've done it, you now have this procedural thing that it just works. I think beyond this, you could expose a couple more parameters, but I think that's the essence of the Geonodes thing. And let me just show you quickly how to do some material. So, by the way, for the people who aren't aware, or the people who are aware and are going to be angry, yes, there are material nodes, like you can assign a material and stuff like this. The issue is because I want to make it kind of like this alternating black and white thing. Because of that, I need to actually make a material for the circle that I'm copying over and over again because it's kind of like the particle that we're instancing. And the issue is here, we just kind of import it in, and it's not like part of this node network, which is why I would like to have another geometry input here that I could connect so I can actually mess with it and look at the Z height, whatever. So long story short, I'm going to set this back to 50. Long story short, I'm going to do this in the normal material editor. Whatever. It is possible to do in Geonodes, just not in the obvious way that I would think. So what we are going to do is I'm going to select the circle, the thing we're copying over, and make a material. So it should be that whatever we change here is copied to all the instances. So you can see it's not dependent on the Geonode tree, but the circle. We're going to make a material. We're going to call it BW, black and white, not boy wonder, not me. We need to make a material. So what I'm going to do is I'm going to take the position input. So this is kind of like the position attribute in Geonodes in some sense. It just looks at the X, Y, Z coordinate of every point on this surface, okay? I'm going to take that. I'm going to look at only the Z coordinate. So just like before, this is why I like nodes better. They're just so much faster. Or sorry, shader nodes better. They're just so much faster. Okay, we've separated it. I'm looking at the height. That again goes from 0 to 5 and is divisible by, it goes in increments of 50 since there's, I think, we made 50 copies. You know, we could change that. Either way, what I'm going to do is to make it alternate, the idea here is I'm going to take the Z coordinate and I want to say make every other one black and then white and then black and then white, etc. So I think the way we want to do this is first I'm going to take this, I'm going to multiply it by, I'm just going to try something here. I believe the number's 10. We'll check on that in a second. And then I'm going to take modulo 2. And we also want to round up, I believe. Something like that. So that should be, yeah, I think that is every other one. Black, white, black, white. Okay, so now let me explain what I'm doing here. So what I've done is I've taken the Z coordinate. I then multiplied it by 10. Why did I do that? Well, because there are 50 circles. We made a resolution of 50, and it goes from 0 to 5, the original line. So you divide those two numbers, you get 10. That's kind of like the increment kind of situation. Either way, you take the two numbers, you divide them, you get 10. This part of the tutorial isn't as relevant. I'll probably come back to this once it's easy in Geonodes. I multiplied it by 10. I then rounded it up to the nearest integer so that there's no point whatever, whatever, whatever. So we just have a bunch of numbers now, bunch of integers. And I said, take it and do modulo 2, which basically says take the input, divide it by 2, and look at the remainder. So the remainder is either going to be 0 or 1, I believe. Which means make it black or white. It's kind of like if you were to look at a clock, which goes from 0, 1, 2, 3, 4, 5, and then up to 12. Well, once you get to 13, it rounds back to 1, right? And probably not the best explanation, but modulo basically says, in this case, we are rounding back down to 0, 1, 0, 1, 0, 1. We're not going above 2. Either way, don't worry about this part too much. This is just how to give it kind of a visual pop. What's really important in this tutorial is the Geonodes. So we have all these parameters, and we have, it's a good life. It looks cool. I think to make this look interesting, I'm going to slow it down. Nope, that's the other way. I'm going to slow it down significantly, so it's this nice hypnotic thing. And maybe I'm going to take the spread and bring it a bit down towards the center, so it kind of looks like these are waves propagating from the middle, and maybe even bring down the resolution. I don't know. You can get a bunch of different looks from this thing. Either way, I think I've said my piece here. I'm just rambling at this point. So, 30-minute tutorial about geometry nodes. There you go, boys. So, hopefully you learned something about geometry nodes. I'm going to experiment more with this, maybe come up with more like simple-ish projects, nothing crazy. Things that kind of teach you the thing and make cool renders, stuff like that. So look forward to that. And of course, this blend file and any blend file I've ever uploaded before is going to be available on the Patreon, link in the description. So yes, Patreon, this is the part of the tutorial where on the right side, I list not like nearly 800 vertices we made on this line, right? But no, it's a list of patrons. So patrons are getting access to a bunch of stuff, like the blend files. They get early access to tutorials. You could have seen this tutorial, in this case, I think a day early. Sometimes it's a bit more. You also get exclusive tutorials every once in a while that I don't post on either this channel or CG Matter. Those are only for patrons. There's a bunch of benefits, Patreon newsletter, shit like that. So check it out if you're interested, or if you just want to support, me and my tutorial making. That's appreciated too. Anything is dank. But Patreon exists, link in the description. Anyways, thanks for watching this deep into it, and I'm sure you learned something at this point, because I did, so whatever. Not saying that I know more than you. I'm just like, oh, I learned something. It'd be nice if you did too. Anyways, that's it. Geometry nodes is here to stay, I guess.